This video is about binomial expansions. Binomial expansions are when we take a bracket with two terms in it and apply a power. The rule for binomial expansions looks like this. We have n choose 0, our first term to the power of n, our second term to the power of 0. Then we have n choose 1, we reduce our power on x by 1, and we go to y to the power of 1. And we keep reducing the power on x by 1 and increasing the power on y by 1 until we end up at n choose n, and x is to the power of 0 and y is to the power of n. This rule is to be found in the log tables on page 20. The formula for the general term of a binomial expansion is also on page 20 of the log tables. They don't write it exactly like this, but in essence what they're saying is the general term, which is tr plus 1, is n choose r, x to the n minus r, y to the r. I'm not going to focus on general term in this video. I'm just going to focus on basic binomial expansions with a view to using those then in a later video for complex numbers and proving trigonometric identities. So here we have an example, fully expand a plus 2b to the power of 3. So in this question, the a is the x from the rule, the plus 2b is the y from the rule, and 3 is our n. And just notice there that in identifying y, I've included the sign in front of the 2b as part of the y term. This is particularly important if that sign is a negative. So if you've seen this type of question before, now is the time to pause the video and give it a shot yourself, and then play and see if you're correct. Okay, so looking back to our rule, we can see that it starts off with n choose 0. So our n in this case is 3. So we're going to start off with 3 choose 0. Our x goes in next to the power of n. Now x in this case is a, and the n is 3. I'm putting a bracket around the a. If in doubt about whether to put brackets in or not, then do. 2b is our y, and we're going to put that to the power of 0. Okay, that's our first term in our binomial expansion completed. Now we're going to keep going through 3 choose 1, 3 choose 2 until we get to 3 choose 3. So 3 choose 1. So I'm now dropping the power on the a by 1 and increasing the power on the 2b by 1. And 3 choose 2. And again, I'm dropping the power on the a and increasing the power on the b. I'm running out of space. And then finally, 3 choose 3. Drop the power on the a and up the power on the b. So it's like a is coming down the steps of the stairs and 2b is going up the steps. Things to note about our binomial expansion at this stage. Notice that the 3 and the 0 make up the total of 3. The 2 and the 1 make up the total of 3, and that's the same for every set of powers that I come across throughout the binomial expansion. Now I go to my calculator to evaluate my 3 choose 0, 3 choose 1, and so on. So 3 choose 0 I evaluate as 1. And a to the power of 3 is just a cubed, and 2b to the power of 0 is 1. 3 choose 1 is 3. A to the power of 2 is just our a squared. 2b to the power of 1 is just 2b. 3 choose 2 is 3. A to the power of 1 is just a, and 2b squared is 4b squared, because notice that there's a bracket around the 2b term, and the squared is applying to both parts of that. And then finally, 3 choose 3 is 1, a to the power of 0 is 1, and 2b to the power of 3 is 8b cubed. And then to finish up, I just need to multiply out each term fully. So I've got 1a cubed, or a cubed if you like, plus 6a squared b, plus 12ab squared, plus 8b cubed. And there's a really nice predictability about binomial expansions. They'll always follow this same pattern where I start at n choose 0, up my values at the bottom of the combination until I get to the same value top and bottom, starting at n, reducing each time, starting at 0, increasing each time. The main things to watch out for really are signs as usual, and brackets. Okay, let's do a second example. So fully expand 2x minus y to the power of 4. So I'm just taking a moment there to clearly identify the components. I've got 2x, I've got minus y, so not just y, but minus y, and I've got a power of 4. So now when I go to do my expansion, I'm going to start at 4 choose 0. So 4 choose 0, and the first term to that full power of 4, and that second term to the power of 0. And then I'm working up 4 choose 1, and I'm reducing my power on the first term, and I'm increasing my power on the second term. And then 4 choose 2, and I'm reducing my power on the first term and increasing my power on the second term. And then 4 choose 3, reducing the power on the first, increasing the power on the second, and 4 choose 4, reducing the power on the first, increasing the power on the second. And I know that I'm finished when I've gotten up as far as 4, because that's my n value, that's the highest I can go. So now I begin to evaluate. So 4 choose 0 is 1. Again, use the calculator for that. 2x to the power of 4. Don't forget, the power is applying to the coefficient and the variable. So 16x to the power of 4, and then 1. Anything to the power of 0 is always 1. 4 choose 1 is 4. 2x cubed, again, cube the coefficient and the variable. 8x cubed. Minus y to the power of 1 is just minus y. If you like, it might not be a bad plan to put a coefficient of 1 in front of the y, just to make it more obvious what the outcomes will be when you put minus y to a power. 4 choose 2 is 6. 2x squared is 4x squared. Now, let's have a look at what I'm talking about here. So I've put in a coefficient of 1 there in front of the minus y. Excuse me. And I can see now that when I'm squaring negative 1. So negative by a negative is a positive, so that's plus 1. And I'm squaring the y, so that's y squared. So you can say 1y squared, or you can just say y squared. And I'm just putting that in just to make it more obvious why I'm getting a positive result here. You might not need to do that. 4 choose 3 is 4. 2x to the power of 1 is just 2x. And minus y to the power of 3, again, if you like, now you can put in the 1 here to make things a little bit more obvious. You end up with minus y cubed. And then 4 choose 4 is 1. Anything to the power of 0 is 1. And minus y to the power of 4, again, stick in that 1 if you like. And that ends up giving you 1y to the power of 4, or just y to the power of 4. There's a pattern here that we can rely on, which is that if we have a negative term to an odd power, we end up with a negative result. And if we have a negative term to an even power, we end up with a positive result. And you can see that in a case like this, we're going to alternate negative, positive, negative, positive. We can see that coming out here, negative, positive, negative, positive. So again, it's all these types of patterns that you can keep an eye out for to make things a little bit easier as you're working out your answers. And now I just need to do a little bit of final tidying up to get my eventual answer for my expansion. So let's have a look. In my first term, just multiply the coefficients together. 16x to the power of 4. Watch out in the second term for signs. That's going to be minus 32x cubed y. Third term is going to be plus 24x squared y squared. Fourth term, again, watch out for signs, is negative 8x y cubed. And my last term there is plus 1y to the 4. You can put that 1 in, or you can leave it out, and you'll be correct either way.